Our planet needs clean energy. Fossil fuels pollute our air and water. We need a better way. Wind power is a great solution. It's renewable and good for the environment. Wind turbines are like giant pinwheels. They harness the power of the wind. This wind makes them spin, generating clean electricity. Imagine a giant fan, but instead of using electricity, it creates it. That's what a wind turbine does. When the wind blows, it pushes the blades of the turbine. This spinning creates energy, just like rubbing your hands together makes heat. This energy is then converted into electricity that we can use in our homes and schools. Wind turbines are an incredible example of how we can harness the natural elements to power our lives. They stand tall and majestic, often in fields or along coastlines, capturing the wind's kinetic energy. This energy is then transformed into mechanical power, which is subsequently converted into electricity through a generator. Wind farms, which are clusters of wind turbines, can generate substantial amounts of electricity. These farms are strategically placed in areas with consistent wind patterns to maximize efficiency. The electricity produced is then fed into the power grid, providing a renewable and sustainable source of energy for communities. Maintaining these turbines is crucial for their efficiency and longevity. Technicians regularly inspect and service the turbines to ensure they are operating at peak performance. This includes checking the blades, the generator, and other mechanical components. The sight of a wind turbine against the backdrop of a setting sun is not just beautiful, it symbolizes a commitment to a cleaner, greener future. By investing in wind energy, we reduce our reliance on fossil fuels, decrease greenhouse gas emissions, and help combat climate change. Wind energy also has a positive impact on local communities. It creates jobs, supports local economies, and provides a sense of pride and ownership. Families can enjoy the benefits of clean energy while knowing they are contributing to a healthier planet. The technology behind wind turbines continues to evolve, becoming more efficient and cost-effective. Innovations in design and materials are making turbines more durable and capable of capturing even more energy from the wind. Despite their robustness, wind turbines are designed to withstand harsh weather conditions, including storms and high winds. Safety mechanisms are in place to protect the turbines and ensure they continue to operate safely and effectively. Environmental considerations are also taken into account. Efforts are made to minimize the impact on wildlife, particularly birds and bats. Research and technology are continually improving to make wind energy as eco-friendly as possible. Wind energy often works in tandem with other renewable energy sources such as solar power. Hybrid systems that combine wind and solar energy can provide a more reliable and consistent power supply, taking advantage of different weather conditions. In conclusion, wind turbines are more than just giant fans. They are powerful symbols of innovation and sustainability. By harnessing the power of the wind, we are taking significant steps towards a cleaner, more sustainable future for generations to come. The blades of a wind turbine are like airplane wings. They are meticulously engineered to harness the power of the wind, converting kinetic energy into mechanical energy. This process is both fascinating and crucial for generating renewable energy. They are designed to catch the wind. The shape and angle of the blades are optimized to capture the maximum amount of wind energy. This design allows the blades to start turning even in low wind conditions, ensuring a consistent energy output. When the wind blows, it creates lift on the blades, causing them to turn. This lift is similar to the aerodynamic forces that lift an airplane into the sky. As the wind flows over the curved surface of the blades, it generates a pressure difference, which in turn causes the blades to rotate. The blades are connected to a rotor, which is like the hub of a wheel. This rotor is a critical component of the wind turbine, as it transfers the mechanical energy from the blades to the generator. The rotor's design ensures that it can handle the immense forces generated by the spinning blades. The rotor spins as the blades turn. This spinning motion is then transferred to the generator, which converts the mechanical energy into electrical energy. This electricity can then be used to power homes, businesses, and even entire communities. The efficiency of this process is a testament to the ingenuity of modern engineering. Wind turbines are often placed in locations with consistent wind patterns, such as coastal areas, open plains, and hilltops. These locations provide the steady wind needed to keep the turbines turning and generating electricity. The placement of wind turbines is a strategic decision that maximizes their efficiency and energy output. Modern wind turbines are equipped with advanced control systems that monitor wind speed and direction. These systems can adjust the angle of the blades to optimize their performance, ensuring that the turbines generate the maximum amount of electricity possible. Technicians regularly monitor and maintain these systems to keep the turbines running smoothly. As the sun sets and the wind continues to blow, wind turbines stand as silent sentinels, capturing the power of nature and transforming it into clean, renewable energy. They are a symbol of our commitment to a sustainable future, harnessing the wind to power our world. Sitting atop the tower is the nacelle. This important part houses the gearbox and generator. The gearbox takes the slow rotation of the rotor and speeds it up. This faster rotation is what powers the generator. Think of it like pedaling a bicycle. The faster you pedal, the more power you generate. Section 5, from wind to electricity, the transformation process. Wind energy is one of the most promising renewable energy sources available today. But how exactly does the wind get transformed into the electricity that powers our homes and businesses? Let's dive into the fascinating process. The generator is where the magic happens. When the wind blows, it turns the blades of the turbine. These blades are connected to a rotor, which in turn is connected to the generator. The movement of the blades is transferred to the rotor, causing it to spin. Inside the generator, the spinning motion creates electricity. This is achieved through a process known as electromagnetic induction. As the rotor spins, it turns a shaft inside the generator. This shaft is connected to a series of magnets. This is possible because of magnets and coils of wire. The magnets are arranged around coils of wire inside the generator. When the rotor spins, the magnets move past the coils, creating a magnetic field. As the magnets spin past the wires, they create an electrical current. This current is known as alternating current, AC, which is the type of electricity commonly used in homes and businesses. The faster the rotor spins, the more electricity is generated. This current is then sent through cables to our homes and businesses. The electricity generated by the wind turbine travels through a series of cables and transformers. These transformers increase the voltage of the electricity, making it suitable for long-distance transmission. Finally, the electricity reaches our homes and businesses, where it is used to power everything from lights to appliances. The transformation process from wind to electricity is a remarkable journey. It showcases the ingenuity of human engineering and our ability to harness the power of nature. As we continue to innovate and improve this technology, wind energy will play an increasingly important role in our transition to a sustainable future. Maintenance and regular checks are crucial to ensure the efficiency and longevity of wind turbines. Engineers and technicians work tirelessly to keep these machines in top condition, ensuring that they continue to generate clean, renewable energy for years to come. In conclusion, the transformation process from wind to electricity is a testament to human innovation and our commitment to a greener future. By understanding and appreciating this process, we can better support and advocate for renewable energy solutions in our communities. Section 6, a look back, the history of wind power. People have been using wind power for centuries. Ancient civilizations used windmills to grind grain and pump water. The first wind turbine to generate electricity was built in Scotland in 1887. Since then, wind turbine technology has come a long way. Section 7, bigger and better advancements in wind turbine technology. Today's wind turbines are taller and more efficient than ever before. Modern turbines can power thousands of homes with clean energy. Scientists are always working to make wind turbines even better. They're exploring new materials and designs to improve efficiency. Section 8, wind farms, harnessing the power of many. To capture even more wind energy, wind turbines are often grouped together in wind farms. These farms can be located on land or offshore, where the wind blows strong and steady. Wind farms are becoming increasingly common as we look for sustainable energy solutions. Section 9. Wind energy around the world, real-life examples. Many countries around the world are turning to wind power. Denmark, for example, gets over 40% of its electricity from wind. China, the United States, and Germany are also leaders in wind energy production. Section 10, a bright future, wind power and a sustainable tomorrow. Wind power is a key part of a clean energy future. It's renewable, sustainable, and helps reduce our reliance on fossil fuels. By investing in wind energy, we can create a healthier planet for ourselves and future generations.